Hey everybody, yeah, so I'm Ryan, head instructor and development lead at HackerU. I'm sure you've heard that a bunch of times now, HackerU. Find me on Twitter at rchristiani. RyanChristiani.com is my website. Let's Learn ES6, so this is a book that I wrote, almost done, and I did a whole bunch of video series, and the comment, worst hands on the internet, this guy, it was like 9 o'clock, it was like a Saturday, I wake up to this comment on my YouTube channel, it's like he's just like really pissed, he's like, very bad typer. How many people typos a lot? Okay, everybody else is lying. Very bad. And when you're recording it, I could edit it a bit better, but he's just like, man, you have the worst hands on the internet. He had 3 comments on various videos throughout the day. It was a wild journey. He watched hours of videos, and then he was like, at the end of every one, he's like, I learned a lot, thanks. I'm just like, why? Stop watching. I'm also an organizer at Node School TO. Any people been to Node School before? Cool, yeah, awesome. If you've never been and you just want to learn, it says Node School, but just learn some JavaScript. It's a self-paced, you come, it's usually at Shopify, so nice venue. Just come, learn some JavaScript, lots of mentors, lots of fun, free coffee, etc. So Let's Learn ES6 is a little book I wrote. If you head on over to letslearnes6.com, you can find a little bit more about that. I also do these little videos called Let's Code Along. That's definitely how I look, and this is my friend here. Yeah, awesome. So at HackerU, React is playing a pretty big part these days. So internally, we build all of our applications with React, besides our main site, which is just WordPress. Also, we have React in our full stack part-time class, and we have React in our full-time course as well. So React plays a really big role at HackerU. And later, come find me or these people who put their hands up over here, because we have lots of React stickers. I noticed there's no stickers. We got some JavaScript stickers. We got React stickers. So come find us. We don't have to talk about anything. You can just say, I want a sticker, and move on from there, because who doesn't enjoy a good sticker? So today, what I wanted to talk about is design patterns. How many people have heard of this term design patterns before? Cool. So we're going to talk about what a design pattern is. We're going to explore some common patterns that maybe you've seen, but maybe you didn't even know you were using it as a pattern. We're going to talk about PubSub, Flux, and Redux. So we're going to talk about these design patterns that allow us to kind of work with data and start to decouple it from stuff in our applications. I've also decided to call this FIT Spotlight Flux, FIT Spotlight Redux, we've heard it a lot, and FIT Spotlight Button. So what is a design pattern? A design pattern is a reusable solution to a common problem. So here's a quote. I'm going to go over here to read this. But each pattern describes a problem which occurs over and over again in our environment, and then describes a core solution to that problem in such a way that you can use this solution 1,000,000 times over without doing it the same way twice. So this is a quote by a man named Christopher Alexander, and he's actually an architect. So this idea of patterns and pattern languages comes from architecture. It actually comes from the 60s. So Christopher Alexander is kind of this considered to be the father of the pattern language movement. So it was his work in pattern languages and patterns that actually helped start to influence programming language design early on. And again, it's not a new concept. This idea of these patterns is not new. It goes back to early days, so like the 60s, 70s, when programming languages were starting to become a little bit more verbose, a little bit bigger than just like assembler and stuff like that. Cool. So again, patterns help us identify problems and then allow us to pick appropriate solutions. So it allows us to pick from a catalog of kind of trusted abstractions. We're not just coming up with solutions. Once you start to learn about a design pattern, then you see a problem in your application, you'd be like, oh, I think I know how to solve this problem. So I really like this quote from Wikipedia. So for instance, in Christopher Alexander's work, bus stops and waiting rooms in surgery centers are both within the context of the pattern place to wait. Because if you think about it, they both share the same sort of context. The surgery center definitely has more going on, but the initial pattern there is the same as when you go to a bus stop or a doctor's office or the dentist or whatever. So in 94, 95, this book came out. It's referred to as the Gang of Four book. Does anybody have this book? A couple people? Awesome, yeah. If you don't have it, it's a really great book. It's called the Gang of Four book, but it's, what is it called, the actual name? It's Elements of Reusable Object-Oriented Software. But it is a book that these 4 authors got together and sort of collaborated on to bring under one roof a whole slew of different design patterns. So the book breaks design patterns into 3 different types. There's the creational types, so stuff like factory pattern. For us in JavaScript, we have like factory functions, stuff like that. Also the singleton pattern, so if you've ever just used like a single object, and we'll actually see this a little bit, that's sort of a creational pattern. Excuse me. Then we have structural patterns, so like the facade pattern. When I think of the facade pattern, the best example I have is something like jQuery. If you call like .toggle or .add or .toggle class, .add class, it's a facade. That interface, that API is a facade for so much that potentially goes on underneath the hood. Like calling $.ajax, like if you look at the code, there's so much going on, but the implemented interface is like a facade for all of that. Structural things would be like decorators as well. And we're going to talk about sort of behavioral patterns. So we're going to talk kind of about the observer pattern, more importantly, the pub/sub implementation of this idea. Cool. However, all these examples are in C++ and Smalltalk. How many people know C++ and Smalltalk here? Okay, a couple people. So unless you know like the whole idea of concrete types and interface and stuff like that, it might be hard to reason about the examples in this book. Thankfully, Addy, how many people have seen this book before? This is a really great book. So Addy Osmani wrote a book a couple years ago, and it's actually free online. You can just find the GitHub for it if you want. But takes these patterns and some other patterns that we commonly use in JavaScript and breaks them down into this book. Really, really great book. Highly suggest it. So patterns are everywhere. So for example, MVC is a pattern, right? Model View Controller. And this pattern itself is actually made up of many other patterns. So once we start to understand these patterns, we can take larger abstractions and start to kind of look at the component parts. So one of the patterns we see in MVC is the observer pattern, or like the pub/sub, publisher, subscribe pattern. So again, yeah, learning these large patterns can help us dissect, learning these little patterns can help us dissect even larger patterns out there. So let's look at some patterns, some examples of things that maybe you've been doing this for a while, but you didn't actually know that it was like kind of a pattern that we've been working on for a while. How many people do this when they write kind of a very simple application? They namespace their application. So you kind of start with this idea of like one app object, like a singleton object. You're not creating new ones of this, you're just creating one object. Then we start to organize our code into like our properties and our methods. This allows us to take our code and stop polluting the global scope with new variables. We introduce one new global variable, so we're kind of solving a couple problems with this pattern. One of the problems it solves is name clashes. So the code you're introducing on your page, and then if somebody's introducing like Chrome extensions or third-party JavaScript onto your application, you're not going to clash with any of the variable names, so it's giving us some safety there. And similarly, we're not polluting the global scope, right? We're not just introducing like 100 new variables into the scope of our applications. And ultimately, it's a solution for spaghetti code. How many people have seen this pattern before, the module pattern? Yeah? So this pattern's fairly popular, although maybe not as much anymore. But the modular pattern was a pattern that allowed us to sort of like mimic privacy in our applications. We don't have this ability to have private keywords and stuff like that. So we use the power of functions and objects to create this privacy. So the modular pattern is a pattern we use in JavaScript specifically so that we can actually emulate privacy. And we do that through closures, functions, and objects. Again, we don't, or for a while we didn't have classes, and even with classes, we don't have the ability specifically to be like private variable, right? We can do some of that stuff with like symbols, but it's a little bit weird still. So the idea here is that when you have a module with this pattern, you have stored onto a variable, an iffy, that just returns a new a new object for you. And this new object is sort of the public interface for our module. And then anything we define that is not returned by this is sort of private. It's locked off. It's hidden away from the user, the other developers using this site, or even ourselves, so that we're not like, oh, but I'm just going to like change that variable right here. It provides some safety for us. So this pattern, it allows us to create privacy. I worked really hard on this next emoji for this one. It allows us to create interfaces. I didn't know what I was going to use for an interface, and then I found all these buttons, and I was like, yes, crushed it. Okay, so managing state. Going back to a Pepe Sylvia situation here. We've all been here, right? So, This one's for Alex over here. So the whole idea, if we go back to actually Pepe Sylvia, managing state in our applications can be really difficult, right? If we don't have a pattern to do this, it's kind of a crime wall situation. You have red twine going everywhere. This thing talks to that thing, but it gets the data from here, but you need this other one to come back first, and it's just like kind of all over the place, right? So one of the patterns that's really popular to help start to solve this issue of managing our state is the publish-subscribe pattern. And this is a popular variation on the observer pattern. I didn't go too much into the observer pattern because it involves a lot more, and I didn't want to spend too much time specifically on that, so we're going to look at this pattern instead. So it's a really simple kind of event system. The idea is that it has, it's an object that has two methods on it, in my case at least, a subscribe message method and a publish method. And the idea is this. You have your publisher, and these two inboxes have subscribed to that. So when this publishes a message, the data can flow into those. And from this inbox, maybe it becomes an outbox, and it publishes like a new message that kind of like completes the cycle. So really basically, like this could be our publish method. Takes an event, takes some data, looks through a listener's hash, so just a simple object that has basically keys that represent our events. If that does not exist, we just return out of this. If it does, it's going to call for every callback inside of there. It's just going to like call all those and send some data along. Subscribe, very similar, takes an event, takes a callback function, so what is actually going to be called and pass that data. And again, checks if it exists on the hash yet. If it doesn't, creates the space for it. And initializes an empty array, so you can push into that. So you could have many, many things subscribed to the same event, which is helpful. Then we get the index, and more importantly, this here, we return, so we implement a remove method so that if we want to unsubscribe or like remove that attachment, we can do so when we subscribe right away. Okay, this is an amazing example. Okay, you ready? We're gonna click plus, wow. So what we have here is we have two areas. We have like a UI area up here and a UI area up here. This plus button publishes an increase event. So these two areas are subscribed to the event, and it allows us to kind of have this, this easy to manage data flow now, right? Same thing happens with the minus sign. So if I click on the minus sign, the areas are both listening to this. However, this area is listening for increase, decrease, so it's actually increasing and decreasing the data, what we're passing along. This one's just listening on both of those events. So now we're able to take UI components and start to subscribe them to specific events, so to specific actions. Cool. So hooking it up real easy, we've introduced this new pub/sub object. We're able to subscribe anything we want on it. We could store this in a variable if we wanted to remove it later, but we don't worry about that. So in this case, we're just coming up with this name of increase. So this allows us to subscribe to an action. Now, I'm going to say action because when we start talking about Flux and Redux, that's sort of the idea there, right? But they're really just kind of events that are happening, or actions, I guess, that are happening on our UI. And we register our event, or sorry, our callback. Same thing, but when we want to publish an event, we can just call the publish method on pub/sub, say what event we're publishing, and then give it some data. So anything that is subscribed to this will get that data passed to it. Again, the core concept here is it allows you to register UI components to specific events or specific actions, not Pacific. The ocean, starts to decouple data from our view. So instead of just things living and sort of specifically being called from there, we're starting to have a little bit more of a centralized section. Not quite yet. We'll talk about that more when we get to like stores in Flux and Redux, but we're starting to get that idea going. So Horace actually touched on this a little bit, but Flux was a pattern that was introduced by Facebook a couple years ago, maybe. I don't remember exactly. And for them, again, like Horace said, it did kind of fix this famous bug they had, right? And I feel like I definitely saw this. When you were on Facebook, you had a message, your little message drawer popped up, you had seen the message, but it still said you had a message. You would go to the full messages, but it was like, it still said you had one unread message, but you had no unread messages. Imagine the data flow in an application as big as Facebook. Like, it's going to get out of control fast. So I introduced this idea of Flux. When I post my links, you'll see it on Twitter. I linked to the video that has this. I would highly suggest watching this because this is their first introduction of Flux and why specifically they decided to go with this. One thing that's really important is Flux is just a pattern. Redux is also just a pattern. They're not specific to React. They've utilized it with React, but they're not specific to React. So you can actually introduce Flux into anything you want. All of my code examples here today have no React in them at all. Even the Redux version that I'm going to show you, it's a counter. Just going to spoil it there for you now. But it's really important to remember that when we're talking about using Redux, you don't necessarily have to incorporate it into React. And I think Wrangle, for example, they use Redux a lot with Angular. Like, you don't have to keep it with React. So what Flux introduces is this idea of more of a singular data flow in your applications. It also introduces stores and actions and a dispatcher. So it doesn't have a publish method anymore. We now have this dispatcher that will dispatch all of our actions. And it dispatches these actions to stores. So Anna was talking about actions. Horace was talking a little bit about actions. We'll see some actions in action. But our stores now become the thing that hold our data. And the idea, again, is you dispatch actions to your stores. The stores will handle the data change, and then you kind of go from there. So again, sort of the idea. A dispatcher dispatches actions to a store. It goes to the component that's subscribed to it, and then the components can dispatch an action, and you just kind of keep this cycle going. No fun animations on that one, I'm sorry. So stores, this idea of a global store is great because now we're starting to get to the point where our data can live in specific places. With Flux, you create multiple stores. So you can have a counter store, like a tweets store, stuff like that. You now have specific places where that data lives. And then all of your UI components can just get from those stores, as opposed to having that data living in all of your UI components. If they share state, if they share data, you should be getting it from a singular place as opposed to multiple places. So with Flux, unlike Redux, there are many stores, and it's up to you how you actually implement your store. So a really common implementation of a store, if you're basically doing any JavaScript work now, you're definitely using a build tool that requires Node. So you could just extend a new class from the event emitter from Node, if you wanted to, or any event sort of system in JavaScript. But it's basically a very simple introduction of a store. So we have a class that has, in this case, just a counter value. And I'll show you the actions in a second. So again, it centralizes our data and starts to decouple it from specific components. So we're getting away from this. There's no other fun image after that. Dispatch an action. So just like we would publish an action with the pub sub, now we have this dispatcher. So this is something that's implemented by Flux, and that's actually about it. So Flux, again, is a pattern. There's no real big library for it. They do have their own dispatcher kind of thing and a few other utilities, but it's kind of sort of up to you to bring it all together. So you have the dispatcher, and you dispatch an action. So in this case, we're dispatching an increase action. And like Redux, you can actually put any data you want on there, or if we're just increasing something by 1, we can just dispatch it like that. We can subscribe our specific components to the store. So the store itself is the thing that actually says when it's changing. So in our case, we have a counter store. On change, we would do something in our component. Again, the data lives in the store, but our components, many components, could be listening to specific stores to change their actions. And then, very importantly, we need to register or subscribe to this. So we can use the register method on the dispatcher to take our action handler from our store, which looks something like this. So this is very similar to if you've ever done Redux. Basically, our action handlers, our handlers in Flux, are just switch statements. An action type comes in, and actually, different from Redux, you don't have to have a type. Type is not specific. In Redux, it has to be type, but you could be like action type, event, whatever you want. No? Anyways. So in here, basically, increase, decrease, whatever you want, you have to say what you're going to do. And unlike Redux, it's not going to have this idea of immutability because we're not actually given the state. It's up to us to kind of control that. which is why you'd probably want to handle all that stuff with Redux eventually. And so inside of like add counter, you basically increment your count, emit a change, and then in your UI, you could publish it. This is a very exciting example as well. I hope you enjoy this. Wow. Yeah. Thank you. Thank you. Yeah, so again, same idea, right? Same exact markup actually in components, but again, so we click on the plus button, it dispatches an increase action, and both of these areas here are just listening for that, and as you guessed it, wow, you've never seen so many counters in your life. That's not true, actually. How many people are in the Toronto JS Slack, by any chance? There was a guy who posted a repo he just made of like counter examples and like various different things. It's very interesting. So again, we're starting. It's no, I don't know. It's like in my mind the new ToDo MVC. Does everyone know what ToDo MVC is? Yeah, basically when all of these like frameworks were coming out to do like MVC frameworks, like your hello world in a framework is like implementing a to-do app. ToDo MVC is just like hundreds of to-do apps with various different frameworks. Really helpful, but it's like, okay, but what can I do without, like if I didn't want to do that specifically? Anyways, when we're starting to get into this idea, we're starting to break our app up again, right? We're taking the data out of components, and we're putting the data into specific places. So we're starting to like loosely couple our system. All actions, in fact, are passed to our stores. So any store that is registered could actually listen to a specific action, which is kind of nice because we have all these different stores, and we have like decrease going on. And right now I only have the one counter store, but I could have a count. The count would be maybe the thing that's in the top corner over here, because this is just listening on increase and decrease, but it could be listening on those two and just like increasing itself. Yeah, 1 sec. Cool. So this idea of starting to like decouple our systems actually introduces this really neat idea of the law of Demeter, or the principle of least knowledge. Has anybody heard of this before? Cool. Yeah, so the idea here is that when we have these really decoupled systems, this is like the embodiment of this idea. And it's basically only talk to your friends. Be a little antisocial and only talk to your friends. So objects should only talk to their friends, not their friends of friends. So in our case here, maybe our components only talk to our stores for the data. They're not also making AJAX requests and all this stuff, and everything's going around. Cool. So again, Flux is a pattern that was introduced by Facebook to sort of start to solve these issues. And then Dan Abramov kind of took that idea and went a little bit further and introduced this idea of Redux. So Redux takes a lot of the ideas from Flux, but actually introduces a few new things, but it also changes a few other things. So one of the key changes with Redux is that instead of having many stores, you now have one store, and then it introduces this idea of reducers, like Anna was talking about earlier. So instead of having to manage all of these different stores for like specific data, we have one store that's going to become a really big object that takes all of our things, and the reducers can actually, when they go through, and I'll show you what a reducer looks like, when they go through the actions, they can alter any piece of that store that we need them to. You probably make it very specific for the reducer, but you could do that if you wanted to. So now, instead of having to get your data from many stores, like a counter store, a tweet store, email store, or something like that, you have one object, one state, and you can get that from anywhere, which is really nice. Whoa. Are you ready? Okay, here we go. Yeah, it's great. So again, and a working example, I know, it's very exciting. Again, to point out, no React involved here, right? This is just straight Redux. How many of you are learning Redux right now? How many of you are learning Redux in the context of React? Try learning Redux just as Redux. There's actually some really great videos on Eka.io with Dan Abramov, where he talks about sort of the principles of Redux and like shows you the basics of Redux first. Because I think learning Redux in the context of React, you have so much boilerplate. You're providing, you're connecting, your like middleware thunks and stuff like that, and it gets so overwhelming so fast. Learn it in the context of just Redux, learn the pattern, learn the idea, and then when you start to implement it inside of your own application, be it React or be it another thing, you can just learn the other portion of that as you go. Does anybody want to see me increase it a couple more times? Yeah. Woo! Amazing. Cool. So the reducers look very similar to our action handlers in Flux. Except in this case, they are provided the state so that we can act on them. Every reducer is provided the state. And basically, you go through, based on whichever action, you can decide what to do with the state. So in this case, we initialize our state at 0 using some default params there, and then our actions come through. We just kind of switch on those. And when an increment happens, we take the initial state, add 1 to it, and return a new state. It's the same thing with decrement, except we have -1. And if nothing happens, we just return the state itself. One interesting thing that Redux also introduces is now, since it's going to have this singular store, it actually introduces a way for you to start putting your reducers together and using the create store, for example, or like combined reducers and stuff like that. So Redux's store comes with 3 methods, and look at the similarities here. We have a dispatch, a subscribe, and a get state. So if we're going all the way back even to PubSub, PubSub had publish and subscribe. So let's just say dispatch is our publish, right? And then subscribe, and then get state. Subscribe would be the same basically as subscribe in PubSub. Again, to dispatch an action, I feel like we've seen enough of this at this point, but the actions are now being dispatched from the store themselves, because that is, in this case, in the case of just sort of vanilla Redux, it goes from there. So the only important thing here is that we have the type. So what type of action are we dispatching? Otherwise, all of the keys are sort of up to you as to what you want to put there. You could have like an object for your data or just stuff like that. And then you subscribe. So this is kind of nicer than PubSub in the sense that you just subscribe to all actions. Because it's one store, you subscribe to everything. And you can just get the state. What is the state of the store at that point in time? And if this returns, in my case, it only returns a number. But if it returned an object, we could put dot count or whatever we wanted on that to get our data. So another really interesting idea that Redux introduces, is this idea of immutability. Like Anna was mentioning, we never mutate our state. We make a new copy of it and return the new version of that with our changes. And this is actually really nice because if you're using Redux dev tools, you can actually do your time traveling and actually debug a little bit easier. But it also introduces it promotes this idea of function purity. How many people have heard of this idea before? Well, Anna told you a little bit earlier, I guess. But a pure function is a function that has no side effects. It does not alter data it is passed to. So for example, if it was passed an array on an object, it doesn't just like change, like push onto that array and it's like, I'm done. It clones it and then it returns a new version of that with your options. Or in the case like math.random, there's no predictability there. Or, I'll show you an example of a pure function. But here would be like maybe a naive impure function, right? You have a total, your add directly mutates total, right? Here would be a pure function, right? We have an add that takes the 2 values and returns a new one. It's predictable because every time we call add and pass 2 and 3, it's always going to give us the same value. If we have this kind of global variable total, we don't know what total maybe has been changed in somewhere else. So now we have this impure function. In our case, for our reducers, we always, in my case, I'm only doing a number here, but we always return a new version of the state. So it's very common to see basically like object.assign or like array from, stuff like that, where you take the existing state, create a copy of it, add to it, return that new version, so you still have that old state. You can still go back to it in the dev tools later on. Cool. So pure functions, again, help us write more maintainable, predictable code. So kind of a recap. patterns are everywhere. And they're proven solutions to our problems. So if you start to learn about these patterns, and you can just kind of like do it more as an academic sort of thing, but you'll start to see that as you get into problems when you're writing software, you might have solved it one way before, but now you might have a new solution that you're picking from a catalog that you know about to be like, actually, I think the fly weight pattern would be better for here, or the composite pattern would be a better solution for that kind of thing. And there's also more than one way to control your data in your applications. Thanks. I'm also done super early, as per usual. So again, we have some stickers. Find one of us. If you don't like stickers, it's OK. It's fine. I think you should like stickers, though. And does anybody have any questions? Simon. Yeah.
And I don't see that a lot like other places in JavaScript, so I was wondering what in both objects you use in switch.
Yeah, I was thinking about that. I think it's because you can just pass in the case you want to do, so you action.type, and you don't have to every if statement, you're not like, if action.type, blah, 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 blah. I was thinking about that, and I was going to like look that up as an answer, but that is my hypothesis on that. Yeah, I feel like that's a pretty good one. Anybody else? Yeah. Performance implications. I feel like you'd have to get like a really big store for that to be an issue, but I've never read anything or heard anything about. So, sorry, the question was, are there any performance issues if you're kind of constantly creating new states, like copying it and creating another one and just kind of piling up? I don't think so. Like again, you'd have to get like to an amount of data that is just like astronomical for it to be a big issue. But I can't say with any certainty that I don't think that would be an issue. Yeah. If that's a good answer for you. Anybody else? I did see another hand, but no. Yes?
I just want to add to that question that there are libraries like immutability,
yes.
which will optimize, and it won't be calling the whole data. It will still reuse the data that has to change.
Yeah.
So those libraries have different.
Yeah, and actually that's a good point. Again, sort of one of the great things I find about React and Redux and sort of this new ecosystem that like Horace was talking about is it does introduce a lot of new libraries. I really crushed that line there. Where there's a lot of new ideas. Like maybe people had never heard of this idea of immutability, and then they can start using something like immutable.js, and then they start understanding like why this is great. So yeah, there's a lot of great stuff coming out of there, and like clearly some performance gains potentially from using a library like that. Cool. Any other questions? Okay, thank you.